Hi, in this video we will talk about the built-in functions that we could use it for economic cost analysis. And there are several functions that we will learn about and will make it easy for us. And instead of using calculator and find out the like 1 plus I to the power of n, it would be just one single function, and this function is built in by Excel, and this is the beauty about Excel. What we could do here, let's go with the first one, present and value future analysis. For the present value, there are two functions, the PV and the NPV. So when you start analyzing this, you start with the equal sign and type PV open parentheses, and then there are some parameters that you have to include in your equation. Like for the example, for the PV, the present value, you have to put I, comma, n, the number of years, comma, and there's one function that is not necessary, which is, I believe, the payment. So you don't need that. So just skip that and make sure that you put another comma and put the future value. In this way, you could find the present value. There's another equation that we could use it, which is the NPV, or the net present value, and it's easy, simple, and it's if you have a series of values like a long table. We will take examples on how to calculate the NPV and how to use the NPV. So you type equal NPV open parentheses, the interest rate, comma, and select all the values except year 0, because year 0 you have to add it manually because it is already in a present format. You don't add it. It is already in a present format. The NPV function is used when you have so many values, again, that you will need to find a present value for them. Again, year 0, you don't consider it here. One more time. The other function that I would like to talk about it is the future value, and that's very similar to the PV. So you type equal FV, future value, open parentheses, you put the parameter interest rate, comma, number of years or periods, comma, and you don't have to worry about the payment, so don't put anything, comma, and the present value. The function that I think this is the last function that we will talk about, and we will use it in this class, called the uniform series, or the annual payment, whatever you call it, but the scientific term is the uniform series. My term is the annual payment or the annual gain. It depends, and this is just to remind me with the A annotation for that concept. There's only one function, as I mentioned, and this function is used when you have equal amount of cash invested or paid each time over the n time periods. The parameters that we need, or how we build this function or how to use it, is type equal PMT, which is payment, open parentheses, I, interest rate, and number of years, present value, comma, future value. And future value it's optional. You don't have to put it there. So you could do either one, whether present value or future value. Depends on what's the scenario, what's the example is asking for. And the arithmetic gradients, just to make sure that you're wondering why we've learned about it, but there's no built-in function in Excel to find the arithmetic gradient, so you have to combine different functions to conduct the analysis. And the last slide here in this presentation is about how to find all these factors, equations, using interest rate table, using Excel functions, the built-in functions. And this is just kind of a summary for what type of equations or factor or built-in function that you will use and when to use it. So when to use to find the future value f, for example, this is right here on the first row. To find the future value f, if the present value p is given, you use the equation this, f equal p times 1 plus I to the power of n. This is if we need to use equation. Now if we need to use the factor, the interest rate tables, you say f equal to the p times f over p function or factor, comma I, comma n, If you want to use Excel, you say FV equal FV, and you start putting these factors I, N, and the PV function. Just to go back a little bit for one of the examples here that we just finished about borrowing $5,000 to pay college tuition, we used the future value. So on this right side here of the slide, I did listed P, I, F, and N. F is the missing one, so we're looking for F. To use Excel, just type equal FV and select the parameter I, which is the 10%, comma, the N, which is the 5 years, comma, there's a payment, we don't need it, this is an optional, and comma, the present value, which is the $5,000, and that will give you the future value for the $5,000 is $8,052.55. And as you see, this is already in red because this is what you have to pay. So if it's red, that's a negative amount. This is a transaction, so you have to pay it out of your pocket. Okay, just to make sure that you understand this concept, let's do it here very quick. So we have a factor P, I, N, and the F that we're looking for. F is $5,000. I is, I believe, is 10%. N is 5 years. Yes, 5 years. Future value is missing. So what we need to do here, just make it bigger, bold. Okay, and it's gonna table. Okay, so the future value using the FV function would be equal FV, open parenthesis, rate is 10%, number of periods is 5, and now the payment, we don't have the payment, so skip that. Present value is 5,000, close the parenthesis, enter, and this is what Dan has to pay the bank at the end of 5 years, which is $8,052.55. Okay, you type something. Dan will pay $8,052.55 at the end of year 5. Excellent. Well, that's all for this chapter. I need you guys to read the chapter. I posted the chapter, the text from the textbook. So read it, read the examples. There are more examples, and get together with your group to finish the next assignment. Thank you guys, and please let me know if you have any question.